Okay, and now we're talking symmetries. And we've got to give examples of each of these three. Reflection symmetry, an object remains unchanged when reflected across the x-axis. By the way, you can read about these on page 606 through 608. Please do that. So an object remains unchanged when reflected across a straight line. Rotation symmetry, an object remains unchanged when rotated through some angle about a point. And translation symmetry, a pattern remains the same when shifted, say, to the right or left. That should be or there. Now, let's give an example of a reflection symmetry. How about the letter D? We could flip that across that line. We'd still have the letter D, wouldn't we? How about E? We could flip E across this line and we'd still have the same letter. How about letters that do not have reflective symmetry? Let's see, J doesn't, F doesn't, U doesn't. Can you name some more? Okay, that takes care of reflection symmetry. Let's see about rotation symmetry. No, I come up with the letter O has rotation symmetry. The book shows that S does. How about X? We can reflect that, or rotate that, and we still wind up with an X. Z, I think we can rotate that and still wind up with a Z, yes. How about letters that do not? Well, again, J doesn't. K does not. And can you name some more? Good. Now let's go on to translation symmetry. And a pattern remains unchanged when shifted from left to right. Well, here's some patterns. How about the book shows X, 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 and so on. And we could put 0, 0, 0. We could put A. They all have translation symmetry. You could shift them left or right, and the pattern would remain the same. Our final question is, how many reflection symmetries does a square have? Well, let's look at a square. And we can reflect it across that line, so that's one. We can reflect it across that. We can also reflect it across the diagonals. So I would say a square has 4 reflection symmetries.